Let's look at final exam question number 70 in Teach Yourself Electricity and Electronics, 5th edition. Please refer to page 676. The question asks us, when we want to determine the voltage gain of a circuit in decibels, we must ensure that the input and output impedances both have what characteristics? Well, the short answer to this question is D, more than one of the above characteristics. So it's got to be one, or it's got to be two or three of the A, B, C above. Well, as things turn out, it's A and B. We must be sure that there is no reactance in the input or output impedance. That is to say, they have to be both pure resistances. And in addition to that, they have to be the same resistance. That's the only way that we can get a valid, meaningful figure for the gain of a circuit in decibels with respect to voltage. The formula, provided that we have a circuit with equal and identical input and output impedances, that is to say both purely resistive and both the same resistance, the gain, if you want to use uppercase G in decibels, maybe we should just say VG, voltage gain in decibels, equals 20 times the base 10 logarithm of the output voltage divided by the input voltage. So, for example, if the output voltage is the same as the input voltage, this value here is 1. The logarithm of 1 is 0, so we get a 0 voltage gain. If the output voltage is 10 times the input voltage, then the base 10 logarithm of that is 1. 20 times 1, we'd have a 20 decibel voltage gain. If the output voltage is less than the input voltage, then the voltage gain turns out to be a negative number. Now, there's a reason why we insist upon these impedances having no reactance and in particular having the same resistive value. If we didn't impose that requirement, we could take, say, a step-up transformer, put 12 volts AC into it, get 120 volts out of it, that's 10 times the voltage. We could claim that this transformer produced a 20 decibel gain in terms of voltage. Well, in a certain theoretical sense, that's true, but gain and loss in a circuit, when we talk about a circuit having gain or loss, we generally mean that it either amplifies a signal, that is, increases its overall magnitude, or else attenuates a signal, that is to say, decreases its overall magnitude. And a transformer doesn't exactly do that. A transformer can change the voltage, but it doesn't actually make a signal any bigger or any more substantial. If we talk about current gain and loss, we face the same restrictions as we do with voltage gain and loss when we talk about decibels. We have to make sure that we're dealing with a pure resistance and that we have no reactance whatsoever in the circuit, and we have to make sure that the input and output resistances are the same. If we want to talk about the power gain of a circuit, though, then all we need to worry about is that the input and the output contain no reactance. The resistances can, in fact, be different. If we have power input and power output, then we can calculate the power gain in decibels as 10, not 20, but 10 times the base 10 logarithm of the output power over the input power. And we don't have to worry at all about whether these resistances are the same. We need to be sure that they're pure resistances in the ideal case, so we don't complicate things with imaginary power. But if they're pure resistances, they do not have to be the same for power gain. Note that if we have 20 dB, 20 decibels of voltage gain in a circuit where the resistances are the same in the input and the output, then we'll have only 10 decibels of power gain. You can go ahead and work some practice problems out there for yourself, but once again, D as in delta is the correct answer.